7 times 10 raised to the power minus 9, which will give us 3 times 10 raised to the power minus 3. Our answer is C. Question 24. The entropy and enthalpy of a system are a measure of A. Degree of disorderliness and heat content respectively, B. Heat content and degree of disorderliness respectively, C. Heat content of a system only, D. Degree of disorderliness only. Solution. Entropy is the degree of randomness or disorderliness, whereas enthalpy is the energy content or heat content of a substance. Answer A. Question 25. 2 moles of sulfur 4 oxide plus 1 mole of oxygen gas to give 2 moles of sulfur 6 oxide. In the chemical reaction above, the substance that will increase the rate of production of sulfur 6 oxide is A. Manganese 4 oxide, B. Finely divided iron, C. Vanadium 5 oxide, D. Nickel. Solution. The reaction of sulfur 4 oxide and oxygen to form sulfur 6 oxide requires a catalyst such as platinized asbestos or vanadium 5 oxide V2O5 catalyst. There's 2 moles of sulfur 4 oxide plus 1 mole of oxygen gas to give under a catalyst of platinum or vanadium oxide to give 2 moles of sulfur 6 oxide gas. Answer is C. Question 26. N2O4 gas reacts in equilibrium to form NO2 gas. Increase in total pressure in equilibrium reaction above where A. Produce more of NO2 gas in the mixture, B. Convert all the N2O4 gas to NO2 gas, C. Have no effect on the concentrations of NO2 gas and N2O4 gas, D. Produce more of N2O4 gas in the mixture. Solution. In equilibrium system, increase in pressure shifts the equilibrium position to the side with less number of molecules. In the reaction N2O4 gas, which is in equilibrium to 2NO2 gas, there is only 1 molecule of N2O4 on the left, but 2 molecules of NO2 on the right. Thus, increase in pressure will shift the equilibrium to the left with less number of molecules, that is the formation of more N2O4 in the mixture. Answer is D. Question 27. What quality of electricity will liberate 0.125 moles of oxygen molecules during electrolysis of dilute sodium chloride solution? A. 24,125 coulombs, B. 48,250 coulombs, C. 72,375 coulombs, D. 96,500 coulombs. Farad is equals to 96,500 coulomb per mole. Solution. During the electrolysis of dilute sodium chloride NaCl, the ion formed as follows. Sodium chloride will discharge sodium positive ion and chlorine negative ion. Water will discharge hydrogen, 1 hydrogen ion, and hydroxyl, 1 hydroxyl ion. At the anode, the anion, that is hydroxyl ion, negative ion, discharged as follows. 4 molecules of hydroxyl, 1 negative ion will liberate 4 electrons to give 2 molecules of water and oxygen. Thus, 1 mole of oxygen molecule O2 is liberated by transfer of 4 moles of electrons. 1 mole of electron is transferred by 1 farad of or 96,500 coulombs. If 1 mole of oxygen will liberate 4 times 96,500 coulombs. Therefore, 0.125 mole of oxygen will give 4 times 96,500 over 1 times 0.125 over 1, which is equal to 48,250 coulombs. Answer is B. Question 28. X plus Y is equivalent to Z. The rate equation for the chemical equation above is minus delta parenthesis X over delta T, which equals to K in parenthesis S squared Y in parenthesis. The overall order of reaction is A 0, B 1, C 2, D 3. Solution. In general, the order of reaction is defined as the sum of exponents in the rate law. The order with respect to the reactant is its exponent in the rate law. Thus, from the rate equation, delta X in parentheses over delta T is equals to K S in parentheses square Y in parentheses 1 raised to power 1. The sum of exponents in bracket, that is 2 plus 1, is equals to 3. Therefore, the overall order of reaction is 3. Answer is D. Question 29. When a current I was passed through an electrolyte for 40 minutes, a mass S gram of univalent metal was deposited at the cathode. What mass of metal will be deposited when a current 2L is passed through the solution in 10 minutes? A. X over 4 gram. B. X over 2 gram. C. 2S gram. D. 4S gram. Solution. In the electrolysis, the current passed is equals to 1 amp and time is equals to 40 minutes, or 40 times 60 equals to 2,400 seconds. Therefore, quality of electricity is equals to I times 2,400, which is equals to 2,400 I coulombs. Hg of M ion is deposited by the equation. M of one positive ion will gain electron to form M. On passing a current of 2 L amp for 10 minutes, Q is equals to 10 times 60, which is equals to 600 seconds times 2L, which is equals to 1,200 I coulombs. If 2,400 I coulomb is equivalent to S gram, 1,200 I coulomb will be equal to X over 2,400 I coulomb times 1,200 I over 1, which is equals to X over 2G, which now means our answer is B.